Now that we can understand a little bit about evaporation, we're going to look at how vapor pressure is affected by various factors. Now let's look at vapor pressure. Vapor pressure, by definition, is a measure of the tendency of a liquid to vaporize or turn into a gas. Let's look at those same four factors we looked at before that affected the evaporation and see how they affect the vapor pressure. First, we had the type of liquid, then the amount of liquid or volume of liquid, the surface area of the liquid, and finally the temperature of the liquid. How do each of those affect the vapor pressure? Let's start by looking at the type of liquid present, and that specifically is looking at the type of interaction that's present in the liquid. What's holding it together? So those bond strengths that we talked about, what they have to break, that tells us what the vapor pressure will be. The stronger the bond, the lower the vapor pressure. The weaker the bond, the easier it is to turn into a gas, the higher the vapor pressure. What about the amount of the liquid? Well, in this case, it has no effect. How much liquid I have present does not affect the evaporation rate, nor does it affect the vapor pressure. What about number 3, the surface area of the liquid? This does affect the evaporation rate, but it does not affect the vapor pressure. Because pressure is actually a measure of the force over an area, if we change the area, we automatically change the force, which means that the pressure stays the same because they come together. So the surface area does not affect the vapor pressure. And that leaves us with number 4, the temperature of the liquid. And this does have a major effect on the vapor pressure. As the temperature goes up, the kinetic energy increases. Those particles have enough energy to escape from the surface, and so the vapor pressure increases.